Hello, this is a encapsulation of some of our class notes, and this is on the array worker. In class, we looked at this worker object, and inside this box, I'm looking at it as a box, and you can see the box begins with this syntactical notation and ends down here. And as we look at it, we see we have these, everything I made public right here. We have worker. Give the worker an array and tell it how big the array is. And ignore this. That's left over from something else. Or give me another worker and I'll make a copy of that worker. And a destructor. And there's only one destructor, so that's why I say the one and only destructor. Next, there are things. Well, what does this thing do? Well, the idea is it's going to be an array of unknown size. Okay. And I want to be able to display that array, so I have a function called display. This is my interface, everything here. And you don't know this because I didn't put any comments anywhere in here. Shows you how important comments are. That this means 3 columns. This means do not change anything. Change what? This stuff down here. You cannot change anything here. All right. Go into my array and tell me the maximum element. Tell me the smallest one. Tell me the average. Now notice replace. Give me a key, give me a value, but it doesn't say constant because this thing will go inside and change something. Then we have how large is it? Well, that's simply size. Excuse me. Then there are questions on equality. If I have 2 of these workers, are they exactly equal to one another? So worker 1 will equal worker 2 if the exact element d of I is equal to the other one's d of I for all the elements. Otherwise, they're not equal. But what about same as? Again, you can't change any of these two. Well, if you look at the numbers in worker 1, are they the same in both? I don't care what order they're in, just as long as they have the same numbers. All right, next. I want to be able to change things. They call those accessors and mutators, actually. I should have put slash in here. Well, here it is, one called access. You tell me the index number of an element, and I'll let you look at it or change it. That's what that ampersand means. Yes, it is a reference, but the reference is very powerful. It means you actually have access to the element. It's not a copy. It's not a pointer to the address. You have access. Next, suppose you gave me a number inside the array, but I don't want to change it. I just want to look, but don't touch. I use get, and I say, don't change anything. Next, I want to set a value. All right, tell me what element you want to change and what value you want. Next, it's this one. This is the normal, fun-loving operator, close and open brace, to access an array item. And I'm saying I want to be able to use this in my object. And this will work exactly like an array that you come to know and love. All right, closer look at these things. This is a constructor. This one has a special name, copy. Because look, I'm a worker and you're giving me a worker. It's called a copy constructor. And when I'm done, I have to give back information maybe, or give back data. Here's a zoom in on display information, get the maximum value, get the minimum value. Notice I don't have to really say anything here. It's all blank. Because get the size. Get size of what? Well, remember, this whole thing is inside an object. The global variables here are the array, are the size of the array. So I don't have to tell it what array to use. It's a global variable. It's global what the array is. It's global. But also notice comments are badly needed here. This is the questions on equality again. Questions on equality, yes. Here I have two concepts. I have, are they exactly equal, number for number, in the exact position? This one says, I don't care about the position of the other worker's numbers, as long as all my numbers are the same in both. We both have the same numbers. For example, 2 and 3, if I had just two numbers, that's the same as 3 and 2, but they're not equal. Why? Because this is the number 2 and that's the number 3, but they are the same as. Here again are our accessors and mutators. A mutator is this thing. It allows me to change something. It allows me to change something. It allows me to change something. This is just an accessor. It says a getter. Go in there and get that value out, but don't change anything. Notice it's the only one that's a constant. And here's our data at the bottom. Notice it's private. It's encapsulated. I don't want somebody to be able to touch any of this. Now this isn't data. In C++ and in other languages, you get this free thing, a pointer to yourself. Who am I in the code? Where am I located? Normally everyone uses the word this. So I'm saying that this is a pointer to a worker. What worker? Me. This means you're pointing to yourself. So this function will point to itself. And I use the word my. So here's the idea: to err as human, really fouls things up, takes a computer. I remember this was on many offices when I was growing up. A joke, but true. So you give this thing an array, tell it how big the array is. First thing it'll do is say, okay, I want to be the same size as that array. Then it'll ask a question. Did you forget to give me something here? If you did, I'm just going to right away crash the program. So assert cannot be equal to 0. That's what the null pointer is. If it's not equal to 0, I should probably check size too. That could crash me. Size should be greater than 0. This thing says go out and create an array and tell me where it lives. That's what D is. D will point someplace in the computer. There'll be an array created called D. And then I'll make sure it worked. I'll say, did it really work? If it didn't work, crash and burn. And if it did work, take T from the beginning till the end of T and make a copy and put it in D. Here's one where you give me a worker. This object already exists. I'm going to make a really deep copy. First, I'm going to ask the worker, how big are you? I'm going to check the size is 0. I'm much smarter for this code. Then I'm going to ask the system to create an array. Then I'm going to make sure that it did create an array. And if it did, I'm going to go to the beginning of the array in D, go to the end of the array in D, and make a copy for myself. So I get a deep copy. When I'm done, I want to give back that copy of everything. So I use this syntax that says D is an array and give everything back to the system. Where did I take things out? Right here. In these two lines, I used one of them. I don't know which one I used, but both of these two lines create an array. When I'm ready to when I need to know how big the array is, well, I already know the size, so I'll just ask. give me the size. And notice a nice name of the function, get size. And don't dare change anything. Here, the average value. That's just a function. And again, this means put it inside worker. Don't change anything. All right. The sum will be equal to 0.0. Auto will turn this into a double. Start at the beginning of the array that I have. Go all the way to the end of the array. Start with sum. And we see sums is 0.0. Take that answer and put it in sum. Take sum, divide it by size. Well, where's size? I already know where size is. It's inside my object. Divide the two and make sure that the answer is a double and return it this way. Here, this is built in, and so is this function. It's built in as C++'s STLs. These are very powerful tools to learn. Java has similar tools. It says start at the beginning of the array, go all the way to the end, and give me a pointer. This will give me a pointer to the largest element. The reason they use a pointer is when this is written, they have no idea what this is filled with. It could be filled with mooses. So they'll tell you, oh, your moose is over there. So that's what this means. This means your moose is over there, or your maximum number or minimum number minus 4 is over there. The same with max. Get the max element, start at the beginning, go all the way to the end, and tell me, and this it'll do, it'll tell you where the value is. It'll point to the number in memory. This simply means go get me that number. Go get me that number, and when you get it, bring it back to me. Go get that number and bring it back. Here I want to display the data. I have it in columns. Go from the first element all the way to the last, one at a time. Take a look at that element. Now, what one am I displaying? If I divide it by the columns, suppose the columns is 3, that means your remainders for this will be 0, 1, and 2. That's what % means, remainder. If it's equal to, if columns is 3, this would be the number 2. What would that mean? That would mean you already used the number 0 up, you already used the number 1, and you're up to the number 2. It will then skip a line. Otherwise, it'll print a space, a tab. So you'll have number, number, number. Oops, you're on 3, skip a line. Number, 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 using the tab. And then you'll skip a line every time you hit 3. Number, 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 skip a line. And when you're done, you skip a line at the end. Next, I have an array full of items. One of the numbers I want to change. I want to change this item, a key value, to a new value. It says start at the beginning, go all the way to the end, one at a time. If I'm looking at a number and it equals the value that you want to change, over here I change it. It's as simple as that. There is another function we could use. We could use a transform or something, but this is fine. Here I want to find out if two are equal. First, they better be the same size. If they're not the same size, false. Next, I'm going to start at the item 0, go all the way to the end, one at a time. And I'm going to look at my data. If it's not equal to the other guy's data item, then I know we're not equal. Return false. If I go through this whole loop and I never return false, that means they must be equal. So the last thing I'll do is say they're equal. Same as, well, that's a little different. What to do here? How to find if two are the same? 1, if they're not the same size, they can't be the same. Another method would be I could take worker number 2. I use a little w here. Make a clone of it from beginning to end. make a clone of that worker. And then I could look at worker 2 and look at myself, one item at a time. I should be able to find all these items in here one at a time. I should be able to find item 1. If I find an item, I remove it. This way I don't have to find it again. Every time I find an item that it's not at the end of the list, I have found it, I erase it. Eventually, if all the numbers are in there, even if they're out of order, I will find them and erase them all. If when I'm done and I didn't erase it all, that meant there was one item that I couldn't match up. So I'll say, oh, it's empty. Tell me this value. True or false, is it empty? Here's another way of doing it, same as. 1, if they're not the same size, they're mismatched, not the same. What I could do is take my data and the other guy's data and make copies of both of them. Worker 1 and worker 2's data, 2 copies. Put them in order, that is, sort both of them. And then look, if they're sorted and they're exactly the same, item 1 will equal item 1 here. Worker 1's item 1 will equal worker 2's item 1. If this is not the case, then right away I know there's a mismatch. Just get out of here. They're not the same. This code is very nice and easy to figure out and look at. So I think it's the best one as compared to this one or any others. Yes, I'm making the computer work hard doing all this stuff. But look, the idea of these libraries, it's like hammers and screwdrivers. Why use your fist when you could use a hammer? Why use a rock when you could use a hammer? Getting data. Tell me I want to get a piece of data. Use get. First, make sure I'm not going to ask something crazy. Check that I'm not too big or too small. Then just go in my array and bring me back the data. What if I want to change it? Tell me which number data you want to change. Tell me what you want to change it to. Make sure you're not too big or too small. And then turn around and change the value. Next, this operator. It's just using this inside a program. If you put X in here, this would be the X right there. You might draw this on paper. This is what you would write on paper. You would actually use these braces here. You'd use those braces, but this is the function that's called. Check that you're not too small or too large. Otherwise, then crash and burn. Otherwise, just go get that data item. Well, not just the item. That symbol means it's a reference. Tell me where that item lives. Next, here's another one, access. It does the same thing as this. So what I'm going to do is I'll use this function right here. First I'll check, not too big, not too small. And I'll say, use the function we just wrote. Use it right there. Next, someone gives me some data. Here's a picture. I don't know what this is a picture of. Here's a SATCOM communication. I don't know what that is either. I know how big they are. Okay. So I could ask questions now in my main. I could say, worker A, you're going to be the picture. Worker B, you're going to be SATCOM. So worker A will be picture, and I can ask worker A, show me your data. I can say worker A, what's your average? Worker B, what is your average? Worker B, show me your data. Then I can ask questions. Is A the same as B? And this says they're not the same. Let's take a look. 33, They look the same. What could be different? Ah, right here. They're almost the same. They have almost all the same values. So they're not the same. And the major point here is we're looking at a baby array, a little baby array. In the real world, look at your camera. Your camera might be 12 megapixels. 12 meg. That's 12 million numbers in one picture. So picture this, so think about this as though this is a picture from your cell phone or camera. This is a picture from a satellite, and I want to see something about them. Okay, so I hope that was help you with the material we've been covering in class.